Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 9, Determining Perimeter and Area of Polygons on the Coordinate Plane. So here's a classwork example 1. Okay. Jasgy has made a scale drawing of a vegetable garden she plans to make in her backyard. She needs to determine the perimeter and area and know how much fencing and dirt to purchase. Determine both the perimeter and the area. Okay, so the first thing you need to do is read the directions carefully. I still have students answering only part of it. So we're going to determine perimeter and area. So let's do the perimeter first. Perimeter is distance around. So if we're going to fence it in, we need to know how much fencing we need. So the line segment FE is down here, and that is a distance of 1, 2, 3, 4, 5, 6, 7, 8. And I'm just going to put numbers here. It's going to be units because it doesn't say feet, inches, yards, whatever. There's no unit of measurement, so we'll just say units. DE line segment is 1, 2, 3, 4, 5, 6. So this is a length of 6. CD is 1, 2, 3, 4. And CB is 1, 2, 3, 4, 5, 6, 7. This is a length of 7. And AB is 1, 2, 3, 4. And then finally AF should be 13 because I have 7 here and 6 here. I will write 13, but I will check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 13, 4, 7, 4. And notice this 4 plus this 4, if we line them up, would be a total of 8. Okay, so the first thing I write is the formula. Perimeter equals sum of sides. Okay, so the perimeter equals the sum of the sides. So in this case, the perimeter equals, I like to start like at the top and work my way around clockwise so I don't miss anything. So it's 4 plus 7 plus 4 plus 6 plus 8 plus 13. So the perimeter is 7 plus 4 is 11, plus 4 is 15, 21, 29, 39, and 3 is 42 units. It's distance, it's not squared. Perimeter is 42 units. Okay. Now we're going to determine the area. So area equals, well, we need to know what shape we have here. This is an odd-shaped area, so we need to break it into rectangular shapes that we can find areas of, and that's decomposition. So I could draw a line here and make a rectangle up here and one down here, or I could have drawn one this way. I will go with this. It doesn't matter which you do. So now I have a rectangle here with a base of 4 and a height of 7. So area equals base times height. The area of this rectangle is 4 units times 7 units. So the area of the small rectangle is 28 units squared. And then I'll also do the area of this rectangle down here. So let's number these. Area of rectangle 1, I'll call it. And I'll put a 1 here. And this will be area of rectangle 2. So area 2 equals, this is a distance of 6. This is a distance of 8. Area of a rectangle is base times height. So the area is base units, 8 units, times 6 units. And 6 times 8 is 48, and it's units squared. Okay, so I'm still not done. I have the area of one rectangle, I have the area of the second rectangle. Now I need the area total equals the area of 1 plus 2, which is 28 plus 48 units squared. So the area total is 76 units squared. Okay, here's example 2. It says to calculate the area of the polynomial using 2 different methods. Read the directions again. Write 2 expressions to represent the 2 methods and compare the structure of the expressions. So I can look inside this and I can split it up many different ways. The answer key shows one way if you look at that online. But I'm going to do it a different way, just to be different. So I'm going to draw a line segment from A to E and a line segment from B to D. I have just created a rectangle in here. So here's a triangle, a rectangle, and a triangle. Triangle 1 and triangle 3 are congruent. They have the same length and height. So I'm going to label all this up. Since my diagram is a little small, I'm going to write it up here. So I'm going to say AE, line segment AE, which goes from here to here, is a distance of 1, 2, 3, 4, 5, 6. So AE has a length of 6, and so does BD. So BD equals the length of AE, which is also 6. That's here. And AB equals ED, which equals 1, 2, 3, 4. So this is 4. All right. Now, if you look, I have created 2 triangles. And if I draw a perpendicular line to the base, where my base is AE, which is 6, this height is 2. I'll just write that there. And this triangle is the same, 1, 2. So here's how I would calculate this. Area of the area 1, which is this triangle, is equal to the area of triangle 3, and they both are going to be equal to base area 3 equals base times height divided by 2. Okay, so that is going to equal the base, which is AE of 6 units, times the height of 2 units divided by 2. But since I'm looking for the area of one triangle and then an area of a second triangle, and I multiplied the formula by 2 because I have 2 triangles that are the same area, well then the 2's that I'm dividing by in the 2 triangles is going to cancel, and the total area of area 1 and area 3, that's not minus area, it was a dash, area 1 equals area 3, it should have been. But the area 1 plus area 3 is going to be, actually let me do that, that was originally an equal sign, they are equal. So the area of 1 plus the area of 3 is the 2 of them. I hope I didn't confuse you here. The area of a triangle is base times height divided by 2, which I have here. But there are 2 triangles that have that same height and base, same dimensions. So the 2 divided by and the 2 multiplied by cancel, leaving me with a total area of 12 units squared. In other words, triangle AEF is 6 units squared, and the area of BDC triangle is also 6 units squared. The sum of the 2 is 12. Now I need to find the area of the rectangle in between. So the area of the rectangle equals base times height, and the area of the rectangle is the base, which is ED, which is 4 units, times the height, which is AE, which is 6 units. The area of the rectangle is 24 units squared. So now I'm going to take the area of the rectangle and the area of the 2 triangles, and the total area equals 24 plus 12 units squared. So the area total equals 36 units squared. Okay, so that was method 1. I've cleared the screen. Now I'm going to do method 2. Method 2 would be to draw a rectangle around the whole thing. So let me get my ruler here, and I probably shouldn't waste video time with doing this, so let me just get my ruler down here and I'll pause this and come back and I'll have a rectangle around the outside of this hexagon. Okay, so here's our rectangle. So the first thing I'm going to do is measure how long these are, count. So this is 1, 2, 3, 4, 5, 6, 7, 8. This is a distance of 8. And this is 1, 2, 3, 4, 5, 6. So the area of the rectangle equals base times height. So the area of the whole rectangle is 8 units times 6 units. So the area of the rectangle is 48 units squared. Now I have too much area there. I now need to subtract these triangles. So there are 1, 2, 3, 4 triangles. They are all congruent. So I'm just going to focus on one of them. Multiply it by 4, and that'll be the area of the 4 triangles. So the area of one of the triangles equals base times height divided by 2. This base is 2 and this height is 3. So the area of the triangle equals 2, my base, times my height, 2 units, times 3 units divided by 2. Well, the 2's are going to cancel, leaving me with an area total of 3. Units times units is units squared. Now, keep in mind, I have 4 triangles, so I'm going to multiply these triangles by 4, so the area of the 4 triangles equals 12 units squared, because there are 4 of them, and they're all an area of 3. So now I take the area total. So my area total minus my area of my 4 triangles is going to equal the area of the hexagon. So the area total was 48 units squared minus 12 units squared is going to be the area of my hexagon. 48 minus 12 is 36 units squared is the area of the hexagon. Okay, so now it's your turn. Determine the area and perimeter of the following shapes. Do 2A, 2B, pause the video, come back and see how you did. I'm also going to pause the video and draw up the givens and have the equation, start at the equation step of the process. Okay, I got a little ahead of myself before pausing the video and I jumped to 2 by mistake. So this is the solutions to, these are the solutions to number 1 and 2, and all we're looking for is the area. So I've drawn this up. I drew a rectangle outside, and it is a distance of 10 by 9. And then one right triangle in the corner is 3 by 3, and they're all equivalent, so there are 4 of them. So I found the easiest way to do this is find the area of the rectangle equals base times height. So the area of this rectangle equals the base of 10 units times the height 9 units. So the area of the whole rectangle is 90 units squared. And then I'll take the area of one right triangle here, and the area of a triangle equals base times height divided by 2, and the area of this triangle equals the base, which is 3 units, times the height, which is 3 units, divided by 2. So the area total, or not total, but the area of the triangle equals 3 times 3, which is 9 units squared over 2, or 4 1/2 units squared. So that's the area of one triangle. I have 4 of them. So when I multiply this by 4, it's going to be 4 the area of 4 triangles. I'll put a 4 out here, and I'll just call this the area of the 4 triangles equals 4 times a half is 2. 4 times 4 is 16. 16 plus 2 is 18 units squared. So now I need to find the area of the shaded region, which equals the area total. Actually, let me call it area shaded equals the area total minus the area of the 4 triangles. So the area of the shaded region equals the total area of 90. And we're going to subtract the 18 from the 4 triangles. And that is units squared. So the area of the shaded region is 90 minus 18, which is 72 units squared. Okay, so now we have a 1, 2, 3, 4, 5-sided pentagon, or polygon, whatever you want to call it. It is a pentagon. And there's many ways we can do this. We could have drawn a square around the outside and had 1, 2, 3, 4 triangles we're going to subtract. I don't think the triangles were going to be equal. They may have been. I just wanted to represent a different way to do this. So here is the triangle. I just drew a straight line from this vertex down, and then a straight line from this vertex over, creating 1, 2, 3 triangles, and the 4th area is a rectangle. So the area of, I'm going to find the area of area 1, which is a triangle, which is base times height divided by 2. So area 1 equals the base. Now I need to count how many these are. I will use blue to measure these. And it's 1, 2, 3, 4, 5, 6, 7, 8. This is a distance of 8. And a height would have to go right down the middle here, and that's 1, 2, 3. So the height is 3, and the base is 8. So that would be 8 times 3 divided by 2. And I'm going to reduce first and make that a 4. So the area, let me go back to black. The area of 1 is 12 units squared. Now area 2 equals, it's a triangle, so it's going to be base times height divided by 2. So area 2 is, this is 3, and this is 1, 2, 3, 4, 5. This is a distance of 5. So it's the base is 5 times the height, which is 3, divided by 2. So the area 2, should have used red, so it equals 5 times 3 divided by 2. So area 2 equals 15 divided by 2, or 7 1/2 units squared. Area 3 is a triangle. It's right here. And that is base times height divided by 2 again. So area 3 equals, now it's the same as 2, so I'm just going to copy this one. So I'll just say 5 times 3 divided by 2. So area 3 is also 7 1/2 units squared. Okay, so finally we're up to area 4, which is the rectangle, which is 5 by 2. So the area of the rectangle, let's just keep it consistent. Area 4 equals base times height, and area 4 equals a base of length of 5 times a height of 2. So the area 4 equals 10 units squared. All right, so finally we're going to take the area total, which equals area 1 plus area 2 plus area 3 plus area 4. So the area total equals area 1, 12, plus area 2, 7 1/2, plus area 3, 7 1/2, plus area 4, 10, and these are units squared. So the area total equals, well, 7 and 7 is 14, and 2/2 is 15. 15 plus 12 is 27, plus 10 is 37 units squared. So that is our final answer. Okay, so now we're on to exercise 2. There's A and B. Determine the area and perimeter of the following shapes. So the perimeter is the sum of the sides. So in this one here, I've already counted and I missed one. 1, 2, well, if this is 10 and that's 4, then this must be 6. All right, so here we go. The perimeter, I always like to start at the top and work my way around clockwise so I don't forget anything. The perimeter is 10 plus 6 plus 6 plus 4 plus 4 plus 10 units. So the perimeter is 10, 16, 22, 26, 30, 40. The perimeter is 40 units. Be careful, it is not squared, it's not area, it's distance to the first power. Perimeter is 40 units. Okay, so now we're going to find the area. Area equals, now I drew a dotted line here to break this up because this is not a shape we have a formula for. So if I split this up into 2 rectangles, or a square and a rectangle, but it's still a rectangle, all squares are rectangles. Then I know that the area of, let's call this region 1 and call this region 2, and area 1 equals base times height. So area 1 equals 4 units times 4 units. So area 1 equals 16 units squared. Okay, area 2 is a rectangle, so it's base times height as well. Area 2 is going to equal the base, which is 10, and the height, which is 6. So it's 10 units times 6 units. So area 2 equals 60 units squared. So now I take the area total, and that is area 1 plus area 2. So the area total equals 16 plus 60 units squared. So the area total equals 76 units squared. So our answer is perimeter 40 units and area 76 units squared. Okay, here's example B, or exercise B. I have counted all these off screen, and now we need to find the perimeter. So the perimeter is the sum of all the sides, so I always start at the top and work clockwise. 6 plus this 4 plus this 10 plus this 4 down here. Coming up the other side, this 10 plus this 7, and then finally 6. And I'm back to the top and I'm done. So I add these up. 15 plus 6 is 21, plus 4 is 25, plus 10 is 35, plus 4 is 39, plus 10 is 49, plus 7 is 56, plus 6 is 62 units. Okay, now we're going to calculate the area. Now I could draw a rectangle around all of this, find the area of the whole thing, and subtract 2 rectangles, but that'd be 3 calculations. I always look for the simplest way to do something. There's an old saying, why work harder when you can work smarter? So I'm going to draw a line right there, and I have just created 2 separate rectangles. Add them up and we are done. So this will be area 1 up here, and this will be area 2. So I'm going to find the area of area 1. It is a rectangle, so the formula is area equals base times height. Okay, the base is 15, the height is 6, so it's 15 units times 6 units. So area 1 equals 6 times 5 is 30, carry the 3, 6 times 1 plus 3 is 90 units squared. So there's area 1. Now we're going to work area 2. It is also a rectangle, so the formula is base times height. So area 2 equals the base of 4 and the height of 10. 4 units times 10 units. And the area of area 2 is 40 units squared. So I've done two calculations. Now I just have to find the area total, which is area 1 plus area 2. So the area total equals area 1, 90 units squared, plus area 2, 40 units squared. So the total area of this shape is 130 units squared. Okay, that is the end of lesson 9. Go do your problem set. And oh, by the way, smash the like.